This video is brought to you by Sporlan, quality, integrity, and tradition.
Well, we've got a walk-in freezer that is icing up. You can't tell right now, but top to bottom the coil is iced up all the way to the back. Now, I've had another technician come out about a week ago. He defrosted it and he couldn't find anything wrong, so I'm here now. And we're gonna see if we can't get this figured out. So we're gonna jump up onto the roof and see what's going on up there first. Well, that is a little thick. The accumulator's frozen solid, the compressor's over here. So this is a walk-in freezer condenser. The sequence of operation is power comes up to the roof and power is distributed via the defrost clock in this condensing unit, either to the refrigeration circuit through the temperature controller and solenoid valve. Then it turns the system on, or it throws the unit into defrost. So the defrost clock is the brain in this situation. So we're going to open this guy up and start there. All right, we got this guy opened. We're going to pull this cover right here. And my defrost clock, first off, it is 8 a.m. and it looks like it's going on 8 p.m. Pretty confident we set the defrost correctly. Whether or not the customer's been shutting the system off, I don't know. Okay. So we need to verify if this clock is working. Now, what we're going to do is go ahead and actually we're going to stop right now. We're going to turn off power. And I'm going to show you guys. I'm going to loosen this clock and pull it out, and we're going to look at the gears right where it potentially is stuck to see if the clock mechanism is working. This is something that's cool on these old school mechanical defrost clocks, is you can actually see the little timer motor spinning and you can see if the gears are stuck. So I'll show it to you. So very carefully you pull the unit out and you can actually see the little gears moving inside the timer motor. It's spinning, but is the clock moving? So the next step we're going to do is very carefully, because this is energized, we're going to go ahead and mark the clock and we're going to give it some time and see if it naturally moves. But you can also look in here at the gears and you can typically see them moving too. I'm leaning towards a bad defrost clock, but we still need to test a few things to confirm that. All right, so I turned it off, but if you look in here, right there, you can actually see where the gears have been slipping. You can see the shininess on the gear. So this is the timer motor right here, and it just turns a series of gears and it's slipping. So this defrost clock is stuck and it's not moving. So I'm gonna force it into defrost, let it run for a little bit in defrost, try to melt some of the ice while I change the clock, and then we'll get downstairs. We'll probably have to get a water hose in there and defrost it manually too. So while I was getting the defrost clock, I forced it into defrost and bypassed the limit switch just to get us, somewhat defrosted. And it did a pretty darn good job. You can see ice has been falling. And yeah, that's really good. Now, we still have to get in here. There's still a little bit of frost, and in the side panels, the heaters typically don't get in there. So we still have work to do, but we're gonna get up and change the clock, and then we'll get back down here and check and see on the ice. Verify the clock is actually dead. It is. We have no power, so the disconnect switch is working, and we're gonna go ahead and replace this clock. Now, I'm going back in with the same style of clock. People ask me all the time why I don't use one brand over the other, and it really depends on the situation. So I like the idea of the mechanical clocks because you can verify they're working by looking at the gears inside, but you can't go as aggressive on the defrost strategy. So every situation calls for a different clock. Okay, we're gonna switch over the wires, wire for wire. This one right here is my defrost termination. We're gonna leave that disconnected for the time being, but I will put it back on when we're done. All right, we're all wired in on the defrost clock, so we're ready to turn power on. But let's go over this real quick. So this defrost clock, like I said, and the way that this is set up, power comes up through this disconnect switch, runs into the defrost clock, and then the defrost clock is the brain of this walk-in freezer, okay? So the number 4 terminal and neutral, or the N terminal, let's call it neutral, the number 4 in common, or N, sends power on the refrigeration circuit downstairs, and the number 4 is the switched leg, okay? And then 3 and common or N send power to the defrost circuit. 3 is the switch leg. The switching happens from this circuit right here, okay? There's a jumper from 1 to 2, and then basically it decides whether or not to send power to this one or to this one. If you look on the back of here, it happens with these little switches right here, okay? So if we call for defrost, it sends power down through number 3. If we call for refrigeration circuit, it sends power through number 4. So in our situation, the defrost clock was not sending power down through the number 3 terminal, and because it's a walk-in freezer, eventually it would just ice up solid like it was today. So now that we're putting a new clock in here, it'll actually be able to rotate properly, and I still need to put the defrost pins in. Now we're gonna run a 28-minute defrost, which is pretty standard for a walk-in freezer. And then we'll put 4 defrosts throughout the day. The thing that I don't like about this clock is that you can't change the duration of a single defrost pin. If you use a Grassland clock, you can do longer defrosts in the middle of the night, shorter defrosts in the day. Sometimes a more aggressive strategy like that can help, but on a walk-in freezer, to be honest with you, typically it's not gonna, the system shouldn't let it defrost any longer than 30 minutes because the coil will usually get too hot and the limit switch will pop it out. Now, this is my X wire right here, okay? And my X wire sends power to a solenoid on the back of the clock. This is the solenoid right here, okay? So it's always got one side power. This is a 208 volt circuit, and it's looking for the other side of power to actuate this solenoid like I just did right now, and it pops it out of defrost, okay? So right now, if I turn this system on, let's see what happens here. I bet you anything will terminate defrost. So we're gonna go ahead and put it into defrost. Okay, so we're in defrost now, and I'm gonna go ahead and pull that wire off, and I'm gonna turn power on. Because the coil's nice and hot, let's give it a second, make sure that it pumps down, which it'll do, because it's in defrost. Okay, we're in defrost now. So we can prove it by grabbing the number 3 wire right here. Actually, not by grabbing that wire. We need to grab, there's a defrost contactor is what we need to grab. Yeah, so that would be this wire right here, I believe. There we go. Okay, so we're pulling 6 amps in the heater circuit right now. Okay, so we are in defrost. So if I take this wire and touch it to the X terminal, it should terminate. And it's not terminating, so it's making me a liar right now. Something is going on here. Maybe the coil's not hot enough. Let's test. Yeah, the coil's not hot enough for it to terminate defrost, because it should have terminated right there. Yeah, so we'll have to dig into that, but it made a liar of me. But if this was working right and the coil was hot enough, that should have terminated defrost. I'm intrigued though, because this coil is pretty warm, so it should be terminating. So we do need to look into that. This is kind of a big picture thing. We're verifying, even though this may not be our problem right now, we still want to make sure that it's working properly. So I'm gonna put the defrost times in here, and then we're gonna go downstairs and check out the coil. I'm very surprised it actually got rid of all the ice in that super long defrost that I did. So that's awesome. Even over here, all the ice is gone too. So that's nice. So we're good on that. Now I gotta look into this limit switch and why it's not terminating potentially. According to this schematic, here's my defrost termination switch right here. And you got red going to common or N. You got brown or black leaving the switch. So if we're terminating defrost, yeah, we should have power leaving X, and we don't. So yeah, we're not leaving X. Interesting. So our switch just hasn't closed as of yet. And we can confirm it by checking to ground from the switch, and we would have 120 or 110 volts if the switch was closed, and it's not. So the switch is open, not allowing power to pass through it. Looks like it just wasn't warm enough yet because it just terminated. Well, it hasn't terminated because I have it disconnected, but if we check from X to 3, see if I can do this with one hand. If we check from X to 3, now we have 208 volts, or 204. So let's go up onto the roof. We know that all the ice is gone. We'll go up onto the roof and see if we can get that defrost clock to pop out of defrost. All right, you can see that we're drawing current on the heater circuit, so that's good. That means we're still in defrost. So if we take this guy, hold on, that's not it. That's just the solenoid. Okay, so that'll happen occasionally when the pressure in the system comes up high enough. It's just slowly leaking by. And you notice that when that happened, the current went away because there's an interlink contactor right here that doesn't allow this contactor, the compressor contactor, to pull in when the defrost contactor's in. And the compressor contactor is controlled via this low pressure control right here, okay? So it is normal for it to do that. If it happens a lot, then you need to adjust some settings or figure something out. But let's put this here. There we go. You heard the click, and now it just pulled into refrigeration, okay? So we'll turn it off. And that just proved that our heater circuit is working and the defrost termination is working. It just took a little longer, that's all. So I turned off power. We're gonna go ahead and get this connected back up. We need to defrost this ice up here too, so I'll have to bring a hose up for that. We'll get that all defrosted and then go from there. Actually, most of the ice is actually just falling off the accumulator with some gentle love taps. It's coming off, so I might not need to bring the hose up. Just get most of this stuff out of here. Naturally, you're gonna have frost build up there because there's no insulation on the accumulator, but you know, we want to get the bulk of that off because eventually that ice will just continue to build and start to cause problems. Yeah, I was able to knock it all off very carefully. You know, that stuff back there will melt, but got it all off of here. We're good to go. So we're gonna put this guy back together. I see absolutely no need to put service gauges on this unit. The fact that it was, you can look at a lot of different things, okay? First off, this is a refrigeration system with a receiver, so our sight glass should always be clear. No ifs, ands, or buts about it, okay? If it's running, that sight glass needs to be clear. Some things you need to take into account is this head pressure control valve requires extra refrigerant from the normal charge. The extra refrigerant, we have a vague term, we call it the winter charge or the flooded charge. There's no way to tell if it has the proper flooded charge by simply just looking at the sight glass, unless it was the absolute coldest day of the year, which is kind of impractical. So on a system like this, we can, if someone marked the receiver level, which I don't see any marks on it, you could pump the system down and check the liquid level after you have the proper flooded charge in there. But this one's not marked. At this point, I'm not gonna go any further. I'm not gonna try to check the flooded charge because I don't see the need at this time. We are also in the middle of the summer. So right now, I'm simply looking for a clear sight glass when it's running. Obviously, you know, I have to be careful with that. The evaporator fan motors need to be running. You need to give it about 5 minutes after it turns on. Then the sight glass should clear up, okay? But we can also look at the way that it was frozen up. It was frozen up top to bottom at the evaporator, front to back, solid, thick ice. A refrigeration problem sometimes will show itself in the way that the coil ices up. If the coil is starving for refrigerant, it might not ice up evenly from top to bottom. You might just get one half of the coil, or if you have a dirty coil or things like that. So I'm kind of using my senses, you know, by the way it was iced up and everything. I don't see the need to put service gauges on here as of yet, but we're going to turn it on. We're going to finish going through the system, watch it come down in temp, maybe 5-10 degrees. I'm not going to stay all day. This customer, that's what they want. They don't want me to wait for hours. If the customer wanted me to, I would stay as long as it takes to get it down to -10, because they do keep ice cream in there, so we want to maintain -10. So I'm going to put the condensing unit together, go downstairs, put the evaporator back together, then we'll turn it back on, we'll watch it come down in temp a bit, and evaluate it further from there. So as I'm putting it back together, look at this. I left notes when I installed this equipment in 2013. So 10 pounds to clear the sight glass, 8 pounds for the head pressure control valve's flooded charge, 3/4, so it actually is at the 3/4 level with the flooded charge in it. Total charge is 18 pounds of 404 by me, 11,713. I still don't think I'm going to need to check the liquid level at this time. I don't see any reason for that, but we'll, like I said, we'll watch it come down in temp a bit. Now, the last thing we should be looking at, I'm going to put the panels on. When this gets turned on, these fans should not turn on immediately. There should be a delay. That same limit switch that terminates defrost also delays the fans from coming on to allow the coil to get cold, so that way moisture doesn't blow off the coil. And it also helps to reduce the load on the system, so that way if you got a warm box, it doesn't just blast the compressor with all that refrigerant and, you know, issues. So we should see a delay, and you'll be able to hear the sound once I get it all put together. So you can hear the refrigerant flowing through the coil, but the fans aren't running yet, and that is correct. It's going to take a minute for the coil to get cold enough. Usually 20 to 30 degrees, I think, ish, is what it wants to see coil temperature. And then it'll turn on the evaporator fan motors. There we go. And you notice the amount of steam that you're seeing blowing off the coil, or frost, or whatever, vapor, or whatever you want to call it. That's what they're trying to prevent, is a lot of that coming out. You're always going to get a little bit. But okay, we're going to go up and check the sight glass now. All right, with the evaporator fan motors running, the sight glass is clear. So we're going to watch this come down in temperature and go ahead and give the customer an all clear to use the box now.
So this started as a callback, okay? But I wasn't upset about it. Sometimes defrost clocks can be a little difficult, and sometimes if you're worried about them, it's best to just set it and see if you have issues again. As long as it's an understanding customer, and this customer is very, very understanding, okay? They get it, and they would rather us come back than just throw a clock at it in a guess kind of a thing, okay? Now, obviously I have a little bit more experience, and I kind of know the things to look for. So I kind of already had a hunch when I walked into the call that we were going to have a bad defrost clock, okay? The fact that it's a mechanical defrost clock, the old school Paragon, is at 814520 is what it is. It's really easy. You just pull it around like you guys saw in the video. If you can see the timer motor spinning, that's a good sign. You kind of get used to how fast it should be spinning too. I can look at them and say, oh yeah, that timer motor's going bad, or, you know, it's moving like it should be. But then just simply looking at the gears, the fact that the gears were stripped out and you could see that they were slipping with how shiny they were in that one spot means that the clock was getting stuck and not advancing, but the mechanics were still turning, you know, and it was just spinning basically. So I was able to diagnose a bad defrost clock and replace it. Okay, so it was no big deal. It's now been, I don't know, 2.5, 3 weeks or something since I did this service call. So all is well. But I think it's so important to explain the defrost strategy. Now, this is a really basic electric defrost, okay? You know, I don't work on the big giant stuff, but I mean, the big giant stuff still uses the same concept. Sometimes they might go hot gas defrost or some other methods, but this is a real simple, the easiest explanation. It's the best way, or the easiest one to understand, to give you a basis, okay? Just understanding the basic electrical operation really helps out, okay? Understanding that on these very rudimentary walk-in freezer units that the defrost clock is the brain. That's the easiest way to understand it. You know, that thing is the switch that tells the machine to do whatever, okay? Even if the temperature controller downstairs says, hey, it's 90 degrees in this box, if that defrost clock doesn't tell the unit to turn on, it won't turn on, okay? So the defrost clock is the brain. It sends the system into the refrigeration circuit because the defrost clock sends power down to the solenoid valve and the temperature controller. And then the temperature controller says, hey, turn on. If it's not sending power down there, the temp control can do whatever it wants, but it doesn't have power to energize the solenoid valve, okay? So in this situation, the defrost clock is the brain. And when you have freeze-ups like this, I kind of mentioned it too, it's so important to analyze the way that it was frozen up, okay? You know, sometimes I have customers that they want to do things on their own. Like, oh yeah, I defrosted the walk-in for you. In a way that kind of frustrates me because I don't get to see how it was frozen up. And then you say, well, how was it frozen? Well, I don't know. You know, it just had ice all in it. How did you defrost it? I just used a hose. It's like, oh my gosh, how did you shut off power? Yeah, I turned off the breaker. You can't, yeah, that, it doesn't, come on, guys, you know. Sometimes I'm just like, come on, don't do this stuff. You're gonna hurt yourself. The power is controlled from the roof. Which breaker did you turn off? You know, and they're like, oh, the single phase, but it's not a single phase unit, you know. Anyways, that's a whole nother thing. But you know, so it's so important to pay attention. If you're an apprentice, if you're a new person in the trade and you're working on your own, pay attention, because when a senior mechanic asks you something, you need to have the answers. Okay. So if I send someone out and they say they defrosted it and I say, how was it frozen up? Well, I don't know. You know, that doesn't help me. What I'm looking for is, you know, the top 2 inches of the coil was frozen really thick, but there was no ice for the rest of the coil. Okay, that tells me I have a refrigeration problem of some sort, more than likely. Okay, underfeeding expansion valve, who knows, something. Okay, oil logged evaporator. But if it's top to bottom solid, well, then that tells me something too. If there's no ice on it, but it's completely impacted with dirt and grease, that tells me something. You know, so pay attention. And if anything, take pictures, you know, take pictures. One of my technicians, you know, he writes notes down because he knows all the questions that I ask him, you know, and he's like, I got a list because I know what you're going to ask me, you know, and he has this whole thing, even if I don't ask it, because like I told him, even, you know, treat every call like I'm going to grill you. You know, that's what I tell him. Treat every call like that. Write everything down. Take notes. Be thorough, because maybe I will, maybe I won't. But what I'm really doing is I'm teaching him to diagnose the system on his own. And he does really well at it now, okay? Because he takes all those notes, and most of the time he can look at those notes and say, oh, I see what's going on. You know, it's right there in the notes, and it explains everything. So that can help anybody, not even a beginning technician. I mean, even an advanced technician. You know, it's really hot out. It's June 23rd, 2021, okay? And in my area, it's about 100 degrees. I've been working out in the low desert, the Coachella Valley. It's been like 110, 115, even 120 one day. And it's nuts. And you go out there and you work for like 4 hours on the roof and you get jelly brain. Your brain doesn't work right anymore because it's not meant to work in that heat. Okay. You're kind of dying every second you're out in that heat in a weird way. But, you know, I get jelly brain. So even for me, writing stuff down, when I have jelly brain, it helps so much to be able to reflect. Sometimes I just got to go downstairs and take a break, cool off, and I could just look at my notes and be like, oh, you know, that makes sense. I screwed this up, you know. Happened to me just yesterday when I was working on the roof out in the Coachella Valley. Got jelly brain, and it was like, oh man, I should have done this from the beginning, you know. It happens, okay? So we got this walk-in freezer up and running. All is well. The customer's happy. If you guys have not already, please do me a favor and go to my website, hvacrvideos.com. You can help to support the channel if you see anything on there you're interested in. We have some merchandise. We got shirts, we got hats, beanies, sweaters. All of it helps to support the channel. There's a couple other ways you guys can help to support the channel and keep these videos coming, okay? If you guys are interested in purchasing any tools, go to truetechtools.com and use my offer code BIGPICTURE. As of today, it may change tomorrow, but as of today, June 23rd, 2021, if you use my offer code BIGPICTURE, one word, you get an 8% discount on your order, okay? That can really help you out. If you know what you're going to purchase and what you want to purchase, send me an email and let me know, and I can generate an affiliate link. Now, I get an affiliate commission off of that 8% discount. You still get the same savings, and I get a small commission off of that. But if you send me an email and I generate an affiliate link, that also helps me out because I get a little bit more of a commission, and it kind of helps me a little bit, okay? You still get to save the same discounts. The easiest way to support the channel is simply just watch the videos from the beginning to the end, okay? It really does help, and you can let YouTube handle all that, okay? So you guys can also support the channel via Patreon. There's links in the show notes of the videos. You can support the channel via YouTube channel memberships. You can support the channel via PayPal. All of those methods help. Really helps me to keep these things going, okay? I really, really appreciate you guys. Work permitting, it's been kind of crazy lately, but work permitting, I do live streams Monday evening, 5 p.m. Pacific on YouTube. And then I also go live, again, work permitting, on the HVAC Overtime YouTube channel with my buddies on Friday nights about 6:05 p.m. Pacific. And there's a link to the Overtime channel in the show notes of this video, okay? So really, really appreciate you guys, and we will catch you on the next one, okay?